Hello, good morning all. Myself K. Venkateswar Reddy. My pin number is 21955 and today's subject is high voltage engineering. And my topic is about the conditional assessment of the electrical insulation in a high voltage current transformer using annual or sand mix. So as per the introduction, we can say that to assess the condition of electrical insulation in a high voltage current transformer using an oil or sandbox method, the transformer's insulating oil is sampled and mixed with a specific amount of dry sand, then subjected to a high voltage stress in a controlled environment to analyze the breakdown voltage, which indicates the overall health of the insulation. A lower breakdown voltage signifies potential degradation in the insulating oil and paper within the transformer. The oil at sand mixture acts as a representative sample of the transformer's insulation system, allowing for controlled testing of its dielectric strength. So as for the procedure, we have sample collection of a representative sample of a transformer oil taken, mixing with sand. The oil is mixed with a precise quantity of clean and dry sand. So in this picture, we can see the step of transformer which has been connected by pointings. And this figure is known as the schematic diagram of electrostatic voltmeter. And here another requirement procedure is the test setup. The oils or sand mixture is placed in a test cell with the electrodes designed to apply a high voltage stress. Breakdown voltage measurements. Here the voltage is gradually increased until dielectric breakdown occurs and the breakdown voltage is recorded. And as for the measuring purpose, a variable capacitor electrostatic voltage generator generates current proportional to the applied external voltage. The breakdown voltage, which indicates the good insulation condition with minimal degradation. And here we can see the basic schematic diagram of a transformer and its core. And its parts are known as the transformer oil, primary terminals, secondary terminals, radiator tubes, which is used to control the heat of the transformer oil. And as for the advantages, this is useful when source loading is prohibited or direct connection is to be avoided. And disadvantages can be more complex than resistance dividers. Spear gaps. And the concept of spear gaps is this measurement peak voltages by the spark over between two spears of a specified diameter. Measurements. The voltage range which the spark over occurs is used to determine the peak voltage. And its advantages: simple and robust for measuring high peak voltages. And its disadvantages: less accurate for measuring DC voltages and can be affected by atmospheric conditions. High voltages are measured by stepping down the voltage by transformers and potential dividers. And in this panel we can see the basic diagram of a transmission pole, which indicates the wind direction and the high voltage power line, ionized known as the corona ion formation or corona effect, in where the ions transfer charge to pollutant particles charged from dispersion. And in this, the graphical representation, the y-axis represents the dominated upland and the x-axis indicates the subconductors and the voltage capacity of the transmission line. Here the spark over of spear gaps and other gaps are also used, especially in the calibration of meters in high voltage measurements. Transient voltages may be recorded through potential dividers and oscilloscopes. The measurement devices used for measuring voltage is called voltmeter. Voltage is also known as the potential difference between two points. So the voltmeter is always connected in a parallel circuit. In principle, the high voltage test with the DC is quite similar to the insulation resistance test, provided that the voltage quality is high with regard to load group. It can also be used to measure the insulation resistance in megaohms or gigaohms. The high voltages can be measured in a variety of ways. Back measurement high voltages is possible up to 200 kilovolts, and several forms of voltmeters have been devised which can be connected directly across the test circuits. High voltages are also measured by stepping down the voltage by using transformers and potential dividers. Spark plugs, spear gaps, and other gaps are also used, especially in the calibration of meters in high voltage measurements. Electrostatic voltmeters of the attracted disk type may be connected across the high voltage circuit directly to measure up to 200 kilovolts without the use of any potential divider or other reduction method. The force in these electrostatic instruments can be used to measure both AC and DC voltages. The breakdown voltage characteristic is also dependent on the polarity of the high voltage sphere. In the case of asymmetrical gaps, hence gaps where one electrode is at high voltage and the other at low voltage with potential. If both electrodes are at equal high voltage or positive polarity as a symmetrical gap, then the polarity has no effect. However, for impulse measurements, a series resistance must not be used since this causes a large drop across the resistance. In measuring impulse voltages, since the breakdown does not occur with exactly the same value of voltage each time, which is generally specified as a 50% breakdown value, a number of impulses of the same value is applied and recorded is kept of the number of times breakdown occurs, and a histogram is plotted with the peak value of impulse voltage and percentage of breakdown. Here we can see the circuit of the basic diagram from an AC supply to the resistances with multiple levels which can be changed accordingly with a total of the 10 resistors gaps and an amplifier with in parallel connected to a capacitor. These three common methods for measuring high voltage DC inputs using electrostatic voltmeters, spear gaps, and resistive potential dividers. Here's a more detailed explanation of each method. Electrostatic voltmeters. These voltmeters rely on electric field generated by the high voltage to deflect a calibrated pointer, allowing for a direct measurement of the voltage. They are suitable for both AC and DC voltages and are known for their accuracy but can be bulky and expensive. Spear gaps. This method involves measuring the voltage at which a spark or breakdown occurs between two metallic spheres of a specific size and spacing. The breakdown voltage is calibrated to correspond to a specific high voltage level, offering a simple way to assess the voltage level. Resistor potential dividers. These consist of a series of high value resistors connected across the high voltage source. The voltage across a smaller calibrated resistor and the divider is then measured using a standard voltmeter, allowing for a calculation of the high voltage. This method is widely used due to its simplicity and accuracy. And out of these three measuring type of voltmeters, the electrostatic voltmeter gives the more accuracy, but it is expensive because of it can be both used for AC and DC voltages. Since in the electrical machine the accuracy is the most important part, according to all the researchers, with accuracy the maintenance of the voltage and the current levels can be suitable for high risk purposes. As per the spear gaps, this method involves measuring the voltage at which a spark or breakdown occurs between two metal spheres of a specific size and spacing. The breakdown voltage is calibrated to correspond to a specific high voltage level. offering a simple way to assess the voltage level. Thank you.